Okay, here is a quadratic equation. X squared minus 2x plus k is equal to 0. We're going to find k so that we will have a distinct roots, b repeated roots, and c no real roots. Okay, so the discriminant is we have b squared minus 4ac. b squared, we have negative 2 squared minus 4. 4 times a is 1, c is k. That means we have 4 minus 4k. That's our discriminant. And then if we have a distinct root, that means discriminant should be equal to and more than 0. So we have 4 minus 4k should be more than 0. That means we have, if we subtract both sides of the equation by 4, then we have negative 4k should be greater by negative 4. We divide both sides of the equation by negative 4, then we have k should be less than 1. So if we put here now, less than 1, if we put 0, is 4 greater than 0? Good. Negative, negative, if we have negative here in k, negative k, that means it will be positive. It's always equal to 0. Good. So that means k is less than 1 when we have two distinct. This is our A. B, repeated roots. That means our, what do we call this now again? Discriminant is equal to 0. So we have 4 minus 4k is equal to 0. Then we have, if we add both sides of the equation by 4k, then we have 4k is equal to 4. Divided by 4, then k should be equal to 1. So when k is equal to 1, then we have repeated roots. Let's see C. I will put it here and with another color. No real roots, that means our discriminant should be less than 0. So if we have 4 minus 4k is less than 0, then we have if we subtract both sides of the equation by minus 4, then it's 0, and 4k is less than negative 4. If we divide both sides of the equation by negative 4, then we have k is greater than 1. So we have three answers there for A, B, and C. So when k is equal to 1, then this one will become square. This equation will become square. If it's greater than 1, that means we don't have any real roots. Then k should be greater than 1. And then if k is less than 1, then we have two distinct roots. Okay, another example. The same question, but we have a different equation. We have 2x squared plus kx minus k is equal to 0. So for A, it should be distinct roots. That should be the discriminant is greater than 0. So we have 2x squared plus, the discriminant should be b squared minus 4ac. Then we have b squared is, our b is k, that is k squared minus 4. Our a is 2. And our c is negative k. And then we have k squared minus a plus of 8k. So if we're going to factor, have k, and then we have k plus 8, not 8. Okay, if it's greater than 0, then we have k is greater than 0, and then k plus 8 is greater than 0. We subtract both sides of the equation by 8, then k is greater than 8, negative 8. So if we try 7, negative 7, this one will be, our discriminant will be negative 7 times negative 7 plus 8. As you can see, this one is positive, this one is negative, then it is not. So this one is, you need to test if it's okay or not. So if we put here now, here is the negative 8 and here is the 0. As we see, negative 7, that is greater than 8, is negative. So we put here negative. It's not positive. So if we have 5, for example, you can see that it is negative, always negative. So that means if we answer B now, it should be, k should be in between negative 8, greater than 8, but less than 0. That means if we try 10, negative 10, I will write it here. If we try negative 10, negative 10 times negative 10 plus 8, you can see that we have negative here and we have negative there. So to answer A now, we have two possibilities. It should be either k is greater than 0 or k is less than negative 8. It's not greater than negative 8 because the diagram says. Okay? And then C, when no real roots, that means less than 0. Oh, sorry for that. Then it is C that have this solution when it is negative. So we have k should be between negative 8 and 0, greater than negative 8 and 0 according to this diagram. What happened when repeated roots, that means is equal to 0? Then we have either we have k, then k plus 8 is equal to 0. So we have two possibilities, k is equal to 0 or k is equal to negative 8. Another example, we have k x squared plus parenthesis k plus 3 times x is equal to 1. The same question, distinct roots, repeated roots, no real roots. Okay? Then we will have our discriminant. We have b squared minus 4ac. Then we have b squared is k plus 3 plus minus 4 times a, which is k. C is, we need to transfer this. Minus 1 there, minus 1 there. Then we have k x squared plus k plus 3 in a parenthesis multiplied by x minus 1 is equal to 0. I forgot that. So we have minus 1 here. Then we have this is squared. If we expand, we have k squared plus 6x plus 9 minus plus 4k. Then we have k squared plus 10k, not x. We are used to use x, that's why it became x. 10k plus 9. That's our discriminant. Now we're going to answer A. Distinct roots. It should be, our discriminant should be greater than 0. Then we have k squared plus 10k plus 9 is equal to, and is greater than 0. If we factor this one, we have 9 and 1. Then we have k plus 9, k minus plus 1 is greater than 0. Then we have k plus 9 is greater than 0. And the other is k plus 1 is greater than 0. So we will see that is k is greater than negative 9 and k is greater than negative 1. We will see in our line diagram here, we have negative 9 and we have negative 1 there. If I will check, I will test negative 5 for example. Let's see if we will get a positive. With this one, I will check that. Then we have, I will use this. Then I have 5, negative 5 squared plus 10 times negative 5 plus 9 is that greater than 0. As you can see, we have 25 minus 50 plus 9 is not greater than 0. So that means this is negative. That is less than 0. That means if I'm going to answer now C, when our discriminant is less than 0, and it should be in between, it's not x, it should be k. K should be between negative 9, greater than negative 9, but less than negative 1. So to answer A now, it should be k should be less than negative 9, or k is greater than negative 1. You can check that if you doubt it. Repeated roots, that means our discriminant is equal to 0. Then we have k plus 9, and then k plus 1 is equal to 0. That means we have either k is equal to negative 9 or k is equal to negative 1. Yeah, I think I will stay there, and I hope you learned a little bit in my lecture on the discriminant of the quadratic equation, of a quadratic equation. In my next video, I will be introducing the quadratic, function, which is in the form y is equal to, or f of x is equal to ax squared plus bx plus c is equal to 0. See you around, and see you next time.